Hello and welcome everyone. So I'll be discussing a very epic problem and also at the same time annoying one. So the problem name is Hills and Valleys. It was recent 695 div 2. I could not do that inside the contest time. Um, and I also got a bunch of wrong answers here. And I will explain in detail with test cases how to approach this problem and where I did mistakes. So what actually the statement says that yes, you are given a sequence of n integers. Okay, now we will let's describe what is a hill and a value. Okay, hill and a valley. Okay, so a hill is something like this. Okay, if there's some array here, some value here, and this is the peak one. Okay, hill's peak. This peak portion is called the hill, where in this value is greater than the previous one and also the post one. Okay, this is called hill as described here. And what is a valley? A valley is simply looks like this, okay, so let's say here's a value AI, and the values uh, previously the previous value of this is actually greater, and also the post one is also the greater one. So this is what we call as hill and valley, right? Now what are you actually gonna be given? Okay, so we have a intimidation value, which is actually a sequence of the sum of the numbers of the hills and the numbers of the valleys in the sequence. Now you can exactly, okay, one integer in the sequence to any number you want, or let the sequence remain unchanged. You have to find out what is the minimum intimidation value that you can achieve. Now first reading the statements, you might have an idea like, okay, I have to minimize the intimidation value, then I will just want to check whether there is any hill or valley, and I will do the operation on the exact array value, right? Yes, pretty much that's exactly what we're going to be doing, because we have to minimize the intimidation value. We won't go for other values other than hills or valleys, right? So we will look forward to the hills and valleys. Okay, so we will just try to, so we will always go for what? Any hill or valley portion, any hill or valley value, and try to change that. So uh, yes, we're gonna be doing this for sure, that we're gonna be trying to change the value, any hill or valley index. If that is a hill or that is a valley, we're gonna be trying to manipulate that and trying to get the minimum intimidation. Now here is the fun part. Now you might first of all, if I say that yes, okay, I'm given bunch of array numbers, right? Now I'm only allowed to change exactly one array, one value, right? So let's say that that this index is either any hill or valley, okay? And I'm gonna be choosing this index, and I'm gonna be manipulating this one. So if you manipulate this one, what other changes might happen? The changes that might happen, or how much this changing can cause, or which of the indexes will be affected by the changing of this value, which will be which will definitely be the post one and the previous one. As we already know that hills and valleys are dependent on their previous and the post ones. So if you change any value here, the total number of intimidation value also can be changed, and also this value can either become from normal to valley or hill, or maybe hill or valley to normal one, normal type of index, or this might also become something like that, right? So changing one index, which is a hill or valley, will affect only the adjacent values of that changing index. Okay, I hope I made you understand. I'm repeating again. I will change the index that I'm gonna change. It will only affect to himself, itself, and also the previous one and the post one, right? Because of the hill and valleys definition, they work like that. So it might cause changing this index might also cause this index and this index state or situation. They might change. Also the middle one too. Okay, the middle one, previous one, and the post one. Now you might also think, okay, that's pretty easy. I can just find out. Uh, so as changing one value is affecting the three, at most three indexes, right? I will first try to find out whether here is any hill or valley, or there is any hill or valley, right? There is any hill or valley, right? I'll try to do this, right? Similarly, I will try to do something like this. There is a hill. I will try to find out whether this index is hill and this index is hill or valley, or hill, or this index is hill or valley. They're consecutive tree, so I'll try to find out the consecutive tree. I might think about that. And let's take an example for this. uh, let's take an example for this one. Let's say uh, actually for the consecutive three ones, maybe hill or valley, right? Let's take one example for this. Let's try to understand that much more. Okay, so let's take this as we have this, and then here, and let's say here comes another level, here comes another, and yeah, here comes another, and here comes another. Okay, let's assume that these levels are the actual value of some random values of the any array. So, and let's compare the level. What we said, we will try to find out consecutive three hill or valley portion. Is there any of them available? Let's check it out. This is any hill. This is a hill. Okay, absolutely, this is a hill because the pre and the post both are less than him itself. So this is a hill. Let's denote it hill. This is also a valley, right? Because the previous and the post one is also greater than it. So HV, and also this is an hill, a hill, right? So we've got another one, and also here we have also got valley, right? Okay. So what we said, we will try to find out what consecutive three ones. So this can be one case where there are consecutive hill or valley. What would you do? Remember, you would always try to make what? The middle one, you will always try to make the middle one equal to either the previous or the post one, right? So if you just make something like this, let's say we make V equal to the previous H, what exactly happens? What exactly happens is that, okay, sorry, let's make this middle one equal to this, the greater hill, right? The rightmost one. If I made equal to that, what exactly happens? The uh, three values that were hill or valley, they just disappears, isn't it? If you take a look at it, here, it's not matching. Also, it's not matching, and also for this index, it's not matching. Now, you might think that, okay, this might work. So I will always try to find out what consecutive three ones. Whether there's consecutive three hill or valley. If I don't find any consecutive three hill or valley, uh, then I will try to find out whether there is consecutive to hill or valley, right? I'll try to find out that. If I don't even get that too, then I will try to find out whether there is at least one hill or valley, something like that. Let's say at least one hill or valley. Okay, it could something. Come on, let's take this, 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 and this. So how many actually hills or valleys are there? Only one. So you might think that okay, I will just try to find out the consecutive three, if there is any consecutive three hills or valleys. If there is an if then the answer would be the total number of hills or valleys, which means the total number of intimidation value minus how many consecutive are there. How many consecutive? Three. So you might want to think that okay, if I somehow get consecutive three ones, I will just right away make them disappear by allowing that operation that I just did. Also, if it does not appear in the array, then I will what do? I will try to find out the consecutive two hill or valley, if they are available or not. If they are not, then I'll try to find out the consecutive one hill or valley. If I find out that, then it might also work like this. Okay, then so you might want to think that okay, the ultimate result would be consecutive total, the maximum consecutive hill or valley that I get, which will be subtracted from the total number of intimidation value, which will be my minimized intimidation value. Turns out what? It does not happen all the time. It will not happen. I actually did that mistake, but it is important to learn an observation that I just tried to make you understand that you need to draw some test cases to find out. There are also other test cases which I'm going to be talking about right now, which won't fit to this solution that I just talked about. I exactly did the same mistake. Now, what is the special case? Let's draw the special test case here, which won't work for the solution that I previously described. Now, let's check it out. This is the special test case. Okay, comes here, and then goes here, and here comes, here comes, there you go, and also here. So as you can see, what was our approach? I mean the wrong solutions approach. We will try to find out what if I have any consecutive three hill or valley, something like that. Let's try to find out. Okay, this is a hill. Okay, let's denote it. This is a hill, and this is not. Okay, this is a valley, right? Okay, and this is a hill too. Okay, so here we actually found out what is the maximum consecutive valley or hill. Two, right? Two consecutive back-to-back valley hill. Now what we said, we will just subtract from the total number of intimidation value minus the consecutive hill or valley portion. Turns out it will not work here. Let's say what could be the answer? 3, 1, 2, 3, right? 3 minus 2. So in our previous solution the answer should be 1, right? Let's try to let's try to do and try to find out and try to make this result as 1. It won't happen. I will show you why. Let's say okay, so I will just change I will try to change either this or this, right? So if I try to change this value to, let's say let's say I try to find out this. I make the value increased by equal to that. Now, does that make happen that I am subtracting 2 hill or valley? No, I am only subtracting 1 with this, because here this hill is actually staying as hill. It is not subtracting. It is not leveling up. Just look at this. If I try to build up this, it doesn't happen. Okay, it is not happening. Let's do this. Let's try to make equal to this h, right? This h. Okay, let's try to make this value equal to this h. What about now? Okay, this does not, this does look a level up. Okay, this is also leveling up, but I have created a mess where it is exactly at the previous portion, like here. Here I have created a very big mess, because while doing so, while doing that operation, I accidentally made a normal normal value which was not supposed to be valley or hill, is actually becoming a valley by doing an operation inside the consecutive to have a valley or hill group. So it is creating a very big problem here. Now, what should we do to understand that? What could be the proper approach? Well, you might think, so let's jump into the actual approach which you might be doing. Okay, so if let's assume that it is creating a very big mess, right? I have to check a lot of test cases. So why not just go for the brute force? Yes, I'm talking about the brute force approach. How should you put that brute force approach, right? Well, let's not always fall for the index that there is a value or hill. We will check each and every index from this portion to this portion and try to manipulate each and every index by making it equal to either the previous value or the post value. Why am I doing this? Look, when I make that value equal to the previous value, somehow I am actually improving my result, because that value could be any hill or valley. Similarly, I can either make the leftmost equal to the leftmost one or either to the rightmost one, right? That value, look, let's suppose this value, I'm manipulating this value. What should I do? I'm saying to go for brute force, I will try to pass on every possible way, right? Every possible way. What will be that? I will try to make this value equal to that value, and I check the whole result at once, and also uh, by making equal to this value, and also checking the whole result and finding out minimum from traversing from each and every index. Okay, so that's how actually we're going to be doing. We are going to be traversing from this 2th index till the n-1th index, and we're going to be doing the exact thing. We'll just make it equal to the previous one and the post one, and try to manipulate what is the minimum yet, what could be the minimum if I change here. If I manipulate this index, what could be the minimum if I manipulate that index? But that's exactly what we're going to be doing. And you might think that this might be a very lengthy or big complexity, but turns out it's not. You can do that. I'll show you in the code part. Okay, here is the code part. It's very shortly coded, and let's try to explain it. Okay, now what we did here, I'll try to explain each and every line. Okay, now look what we did here. We took the test cases, and here are some pre-values, which is initializing by 0, and here we took the n value, taking the array. And what is this actually doing? This is actually keeping track of whether one actually initializing of something, which is I will tell you here. This is initializing actually the track value. whether that index's value is either hill or valley. We're going to be checking for each and every index from 1 to n minus 2. Actually, this is 1 to n minus 2 because actually I'm referring it as zero base indexing. That's why I'm going for 1 to n minus 2. If it's one base indexing, you would go for 2 to n minus 1. So as it is zero base indexing, let's go for it. 1 to n minus 2 till n minus 2, and checking whether something is hill or value. Now how are we checking it, hill or value or not? Here there is a hill function that indexes value whether it is equal to its less than it to its previous or less than to its post one. And also similarly for the hill, I actually explained you how to do hill and valley, so you would definitely understand these two functions. And we're going to be checking whether one is valley. If one is valley, I'm just returning 1, otherwise returning 0, and I am assigning those values here in this this array, like array is keeping track of whether one index is either hill or valley. And then this is the main part here. Initial answer, and here the count, this count is initializing the initial total intimidation value, and I'm keeping that as the minimum. Okay, keeping that as the minimum so that there might be any chance whether I don't have to change anything, so the answer would then definitely be CNT, or the total intimidation value. Now here's the fun part is here. I'm traversing what I said. I'm gonna traverse each and every freaking index, and I will try to assign the leftmost. Look, I will explain this line later. What I actually did here, what I said, I will assign this index's value equal to its previous index, and I'm gonna check whether what is the output now, right? What is the output that is giving me now? Now, what actually are we doing here? This line, basically, this line and this line are both same because here here first I'm checking whether it is equal to its I'm assigning the equal to previous value, and then assigning to equal to post one value, and then I'm actually comparing uh, two possibilities result, and then I'm minimizing my answer. How am I minimizing? Look here, minimum equal to minimum of minimum, comma, CNT minus what I did here, MMI minus MMI minus 1 minus MMI plus 1 plus what I did here, valley I plus hill I plus valley I minus 1 plus hill I minus 1, blah blah blah. What exactly this line does mean? Look, what I'm trying to find out, the current situation that's gonna occur when I make AI equal to AI minus 1. Now so after I make it AI equal to AI minus 1, I will try to make things from the beginning. I'll try to make things from the beginning. That's exactly why I'm doing CN. What is this line meaning? CNT minus MMI minus MMI minus 1 minus MMI plus 1. What is this meaning? This means that when I make AI equal to AI minus 1, there might be some possibility that I get a positive result, which means I might subtract something. There might be any possibility where uh, this MMI might be, which means I'm trying to explain is that there might be some possibilities. Okay, so actually I'm trying to okay, as I have assigned AI equal to AI minus 1, so I will try to find out what is this result giving me the result, okay, not the previous results, which when AI was there, not AI minus 1 was there. That's why I'm subtracting these values initially, and now I'm gonna calculate what is my current value now after doing AI AI equal to AI minus 1. That's exactly why I am calculating here and adding here if my this value, so now this value is equal to AI minus 1, and I am calculating whether it is a value or not, or it is a hill or not. Look, either one of them would be 1, not both of them would be 1, okay, in each index. So that's why I'm tracking out valley plus hill. So what is this doing? This is exactly doing, I'm actually removing what was before when in I index there was AI, not AI minus 1. That's why I'm removing all the possible outcomes here. The previous one might be valley or hill. The present one and the post one might be. But now I'm deleting that because I'm inserting what? I am inserting a new value. What is that? AI minus 1. And what is this value adding and affecting those 3 consecutive values that I just discussed with you, right? I initially told you that it has relation with its previous and the post one. That's exactly why we're deleting the previous one's expectations and we're adding the current one's situation that it's gonna add, right? So this valley I, hill I, and valley I minus 1, these valleys, because of this, what is affecting? Okay, what is affecting when I make this I here, this AI is equal to AI minus 1. So it will compare for AI minus 1's value. Here AI means AI minus 1 actually. I mean the value that I just assigned here. I hope you understand. I then I'm just gonna do the exact same thing with when AI equal to AI plus 1, right? And I'm gonna do the exact, these two lines are exactly the same, okay? And finally what I did here, AI equal to TT, I told you I will explain you one line later. Here in this line what we actually did was we initially as we have to check all the possibilities, right? So after manipulating the array, we have to take it back to where it was. That's exactly why we are keeping a temporary TT value and assigning it to the previous old one, and then it's assigning back to where it was after our work is done, because we only have to change only exactly one array, only one value each, because we can only change one time, right? So I'm checking out all the possibilities. That's why I have to make it where it was at the end of the loop, or at the end of an operation. Okay, and then finally we're just printing the minimum value. I hope you understand that. It was a very annoying problem to me. I've got like bunch of wrong answers here, and I could not solve even in contest time. So till next time, goodbye, and yes.